For the second part here, we're going to try and finish the last two graphs, tangents and cotangents. The trick with these are you want to try and go from an asymptote to an asymptote. You can really graph them across whatever range you want as long as you get one full period. But these graphs are unique because the entire graph happens between one asymptote. So for example, you go back to the cosecant one. We said one full period was all of this as 2 pi. So we actually have 3 asymptotes with it. So the entire graph doesn't happen between one of them. You only get half the graph here. You get the other half down here. Okay, tangents are actually going to take place between just 2 asymptotes. You go to your secant. We said with these ones, you're going to have kind of 3 pieces to the graph looking like this. So you could, scoot this over and extend this piece out and forget this, and you'd have another asymptote here. So it takes place between 3 asymptotes again. But for the tangents and the cotangents, that's what's going to happen. All right, so we know undefineds and whatnot happen at axes points, because if you go to a unit circle and you think about tangent, we know is the same thing as sine over a cosine. So if you think about tangent should be 1 at anything with 45s, or -1, because the sine and cosine are going to change signs. Tangent at 30 and 60 are going to be ugly numbers, so they're not convenient to graph. So we're going to use 45s, and we're going to see what happens at each of the axes. So we know tangent is the same thing as a sine over a cosine. And you guys have these values in your tables, but it's good to see where they come from again. You're literally just going to make a graph, plot some points, and see what happens. So tangent of 0, this right here is 1, 0. So you know the sine is 0. Cosine is 1, so tangent is 0 equals 0, so that'll be a good point to graph. You come up to pi over 2 up here. This is 0, 1. And therefore the sine is a 1 over a 0, so this is going to be an undefined. We can graph undefined, it's just going to be an asymptote. And then you come over to pi over here. -1, 0, and we know the sine is going to be 0, cosine -1, this comes out as 0. So I said you want to try and go from asymptote to asymptote. So in this case, we're crossing an asymptote. So let's take these two things right here and try and find some better points with them as well. So why don't we see what happens at a negative pi? And the reason I'm using negative pi instead of 3 pi over 2 is it keeps me from jumping through these quadrants you're not going to use, because you're going to find out we're only going to use tangent points here and here, but you don't want to go counterclockwise with these. You want to start down here and you want to come up this way. It's going to be the first graph that actually has something in the negatives. Okay, so negative pi is the same thing as 3 pi over 2. So you put your points in here, sine over cosine, so -1 over a 0 is an undefined. So if we take this and we move it up here, we're going from asymptote down here to asymptote up here. We get a 0 in the middle, and then we're going to use those 45s, because from our unit circle again, we know the tangent of 45 is 1. Tangent of -45 is -1 when you stack these. So if you want to update your little table cheat sheet that I gave you, for tangents, we're going to use these 5 points right here. Okay, so we're always graphing 5 points. These are the ones we're going to use. We're going to start at -pi over 2. So the first thing we're going to graph is down here, and then we're going to come up this way. So you're not skipping over any quadrants or anything. You're going from asymptote to asymptote with some stuff in between. So if you actually plot these right now, you're going to have an asymptote, a -1, a 0, and a 1. So those are kind of increasing points. And here's what your graph's going to look like. The asymptote, -1, +1, and a 0. So the points that we had are these here. And the way you connect them, it's just with, kind of a little curl here. And these things can obviously never, ever cross the asymptote. The unique thing with tangents, the period is pi. It only takes 1 pi for this entire graph to take place. And that 1 pi happens from -pi/2 up to +pi/2, gives you a full pi. So when you give me a tangent, all I want, asymptote, point, asymptote, and a curve. So just one of these is sufficient. Okay, so asymptote to asymptote. If we didn't do that, you'd have like this piece here and this piece here, which gets confusing. So we're just going to go one period in between the two asymptotes. So if we want to do a cotangent then, it's going to be very, very similar. So here's the 5 points we used for a tangent. So if we go use those for a cotangent, we should be able to see what happens. So cotangent is just 1 over the tangent. So undefineds are what happened when there were zeros on the bottom. I guess this would be a negative, but that's not going to matter. So we had an undefined. If you flip an undefined, it goes to a 0. If you flip a -1, because we use that there, it's going to go to a -1. You flip a 0, so you used to have 0 on the top, and you had a 1 here. You flip that, this is going to go to an undefined. Pi/4, for a tangent, it's a 1, so a cotangent, it's also a 1. Pi/2 is an undefined, so you had a 1 over a 0, you flip that, 0 goes on top, and you get here. So now you're running into the same problem we did with the tangent, in that I said we want to go undefined to undefined. These points don't, and you're going to have kind of a mismatched graph. So we're going to forget these ones here, and for a cotangent, we're going to start over here, and we're going to go these two quadrants here. So 3pi/4 is in quadrant 2. The sine and the cosine are the same thing because it's a 45, but the cosine's negative because it's coming back. So this is a -1, and then you come over to pi. So at pi, this is -1, 0, and you know cotangent is a cosine over a sine. If you guys are wondering why the writing's so sloppy, the smartboard bulb is dead, so I have to do this with the mouse. So cosine over a sine, so this is going to give us cosine of -1. Sine is the second coordinate over 0, and then an undefined right here. So for a cotangent, we're just going to offset it from a tangent, but it's the exact same values, they just happen at different x values. So we're going to go 0 to pi instead of -pi/2 to pi/2. So they overlap in 1, but tangents are down here, cotangents are over here. And you'll see a lot of this in chapter 6 as well. So what's a cotangent look like? It's just this. So we said we're starting at 0, we're going to pi. So starting at 0 here, ending at pi over here. That's a pi. And instead of it increasing like a tangent, it's decreasing. So tangents were increasing, cotangents are going to be decreasing. There's the pi/4, 1. There's pi/2, 0. There's 3pi/4, -1. And all I want from asymptote to asymptote, that's one full period. Okay, so same thing again with cotangents. Tangents and cotangents are special because their period is just pi instead of 2 pi like before. So there's the graphs. Get those down on your little cheat sheet, so you should have all 6 filled in now. You got 5 new graphing points for each of these, and in class we can start looking at what we're actually going to do with them.